I'm going to talk a little bit about the circumference of circles. All right, there's an activity we were going to do in class if we were having class, so instead I'm just going to sort of walk you through it, and it's an activity that's done in a lot of classrooms also. I would have given you flexible measuring tapes that you might use for sewing. I was going to ask you to measure things in centimeters because then you can use decimals instead of having to figure out fractions with inches. And then I was going to have you go around and measure the diameter and circumference of several different size circles around the classroom and around the building. We'd collect the results and we'd take averages of each circumference and averages of each diameter so that we could reduce any measurement errors any particular group made. And then we'd fill these into a table that looks something like this. So these are some hypothetical objects and approximate measurements that they might have. And then we would calculate the circumference divided by the diameter for each one. And you might pause and ask yourself if these numbers make you think of anything and why they might do that. Usually around that point in the lesson, someone would say, oh look, they're around pi, around 3.14, and I think that has something to do with the formula for a circle. So what is pi? A lot of people know that pi is 3.14 something, 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 but that doesn't really tell us what it means. We're going to define pi. Pi is defined as the ratio between the circumference of a circle and its diameter. In other words, pi is, by definition, circumference divided by diameter. And because the diameter is twice as long as the radius, we can also write that as circumference over 2r. And if we do a little bit of algebra and just rearrange things, then we end up with c equals 2 pi r, which is a formula many of you probably learned in school for how to find the circumference of a circle. Let's talk about how we can visualize that. I'm going to start with a number line, and then I'm going to put a circle on it. My circle has a diameter of 1, and I'm just going to use that to mark off distances. So this is 1, 2, 3, 4. So we have a little bit of a number line or a scale on our number line here. So I'm going to clear those off and put a new circle here, and it's got some spokes so you can see it spinning. And I'm going to roll this circle along until it's done one full revolution. And as it goes, it's going to mark its trail so we can see how long the circumference of the circle is. Because if it does one full revolution, that means every part of the circumference has touched the line once. So let's see what happens. So it stops at pi. So in other words, the circumference of the circle is pi long when the diameter is 1. And there's another way to visualize what's happening here, which is if I take a diameter, remember our diameter is 1 unit long, and let's imagine that it's flexible like string, so I can try to put it around the circumference of my circle. And so if I try to wrap it around, I can fit 1 of those, 2 of those, 3 of those, and there'll be a little bit more left over. So in other words, I can fit 3 and a little bit of a diameter around my circle. I do want to talk a little bit about the difference between math and science. When we're filling out a table like this and doing measurements and then calculating the value of pi in this way, it's a little bit more like science where we're collecting data and using that real-world data to figure out our values. Mathematicians also like to have other methods to do this, to calculate pi more precisely. And one of the ways they do that is they think about a regular polygon. Here I've got a regular hexagon surrounding a circle, and using that as an approximate value, the perimeter of that polygon is an approximation for the perimeter of the circle. Now here they look pretty different. The hexagon's clearly quite a bit longer than the circle. But as we add more sides to our polygon, it gets closer and closer to the actual circumference of a circle. Now we're not going to go through all the calculations, but because it's a regular polygon and it has certain properties, we can calculate the actual perimeter fairly precisely. All right, so to summarize, pi is, by definition, the ratio of the circumference to the diameter. It turns out to be around 3.14, but 3.14 doesn't really tell us what it means. Another way to think about what that means is that if we try to wrap a circle's diameter around the circumference, it's going to fit a little bit more than 3 times. We can measure real-world objects to approximate the value of pi, but we can also calculate it much more precisely through a variety of methods without measuring real objects.